The Geometrix OhmMapper offers a fast, portable, automatic, and flexible capacitively coupled resistivity system. Over the next few minutes, we'll show you how the OhmMapper can detect changes in the content and structure of the Earth's subsurface. This includes changes in clay, water content, and mineralization, weathering in faults and fractures, depth of sediment to bedrock, contaminated plumes, geothermal activity, shallow aquifers, and location of voids and cavities. Here's Geometrix electrical engineer Tobin Van Vechten with more on the Geometrix OhmMapper.
The OhmMapper consists of two primary modules, a transmitter, which is white, and a receiver, which is orange. First, we take the white transmitter module and we install the batteries. Now remember, this little tab faces up and the battery contacts face out, whether towards the back or towards the front of the module. Just insert them in, and then I snap this knob into place. Now I have to install this protective shield. Now note this little nose points front. It points towards the receivers and the console. So we just slide the cover over, and now we install the cables. This cable in my hands here is one of the OhmMapper dipole cables. Now note the two ends of the cable are identical. Each end is what's called hermaphroditic. They have male and female pins. So it does not matter which end of the cable you plug into which end of the module. The main point to remember is that you need to have the same length cables on the transmitter and all the receivers. If you have a 2.5 meter cable on the receivers, you want to have a 2.5 meter cable on the transmitter. The transmitter has two special adapters that we call shorting plugs. So it's a short little piece, and what it is a safety device. This transmitter can put out 1,000 volts and at a milliamp or two, and so we want to keep you safe. We need to protect these contacts. We want to make sure that you cannot accidentally touch these contacts. So the transmitter has circuitry that forces it to only run if this shorting plug is connected onto the transmitter dipole cable. And you need to have a similar shorting plug on each end of the transmitter dipole cables. This shorting plug, while it provides safety for the transmitter, it also provides a tow point between the transmitter and receiver. This loop here is how you connect the transmitter to the receiver. This here is the dipole cable on the receiver closest to the transmitter. And in my other hand here is another one of the shorting plugs. On the transmitter, the shorting plugs are a safety feature. On the receiver, it is simply a tow point. This in my hands here is what we call the optical wand. It provides electrical isolation from the receivers to the console. There is a lip on this end of the optical wand. This end with the lip goes towards the receivers. The end without the lip goes towards the console. The point of this lip is for the weight. It keeps the weight from sliding past the lip. So we slide the weight down the wand, and now the weight stops at the lip. This weight helps keep the dipole cable on the ground. This is because a cable that's flapping a lot or that's lifted up off the ground will give you reduced data quality. So if we can keep the weight on the ground more, you'll get better data quality. The transmitter has a single power switch right here on the back. You twist it to turn it on, and there are two status lights. The blue light flashes quickly while the transmitter is turning on, as it's doing right now, and the green light is on solid. The green light just indicates power. Once the transmitter is through its turn-on phase, the blue light will start flashing a 3-digit binary code. The simple binary code is short for 0, and a long for 1. So if we're looking at this light flashing right now, short, long, short. So 0, 1, 0. And so binary code 001 is 1, 010 is 2, 0113, so on up to 111, which is 7. So the transmitter has 7 different current levels. This will be important later when you're trying to troubleshoot on the console end. You'll want to make sure that whatever current level the transmitter says it's putting out, the receiver up that way says it is receiving. The receiver setup is very similar to the transmitter.
The OhmMapper from Geometrics can be configured with up to 5 receivers for multiple depth readings with one pass.
The OhmMapper uses the G858 console. This is the exact same console as on the G858 magnetometer.
It's simple to connect the cables, both to the battery source and console, with the connectors being unique for each connection. This eliminates any confusion or connection errors. There's also a standard lead cable that will allow you to connect the OhmMapper with most any standard GPS system.